Today we're going to talk a little bit more about graph theory, and this is the second time that we've talked about graph theory, so I'm not going to go over everything in the kind of detail that we did the first time.
Go for it, yeah.
We'll start with the same diagram that we did last time. Now, the puzzle that we had was to take this diagram and to draw it in one complete motion without taking your pencil off the paper, passing through each of these nodes and across each bridge, only crossing each bridge once, not crossing the same bridge more than once in either direction. You can go through any of these nodes as many times as you want. Now, I gave an example of how someone could try this. For example, I think you could try going like this. The problem is that once you get to this spot, there's no way now to go over these bridges because you're going to have to retrace one of these bridges to get out. So this is an example of a bad approach. Now, I'll try another one where I think it'll work. I'll start somewhere else. I'll start down here. I'll go like this. Let me see, what else can I do? Well, I think it'll work if I go like this. Okay, I did it. I started here, and I finished at the same place. And I passed through a lot of these places more than once. That's okay. It's okay if you pass through one of those nodes more than once. It's even okay that you crossed in the middle. That's not real. Those aren't connected. Those are like bridges that are going at different heights. There's not a node in the middle, so that one doesn't even count. Okay, so that one was one that wasn't that hard. And now we're going to try a slightly different one that we did last time also. It was just like that, only I took these away. And this made it a little bit difficult. And what we learned from the last lesson was that this had 3 bridges, this had 3 bridges, this has 2 bridges, this has 4 bridges, this has 4 bridges. So it has 2 bridges with an odd number. That means this, it could be possible to do this in one complete circuit without picking your pencil off. But if to do that, you had to start at one of them was a 3, and you had to finish at one that was a 3. So you'd have to start at one of these 2 and finish at the other. And I didn't tell you anything about exactly how you would do that. It's just that I said that it's not impossible. Then we also talked about another one, which was this. Oh, I'm sorry. Let's see. It was this one. Now this one, this has 3 bridges. This has 3 bridges. This has 3 bridges. This has 3 bridges. We talked about how this one was impossible. You could try as many times as you want, you'd never get this one. We talked about that. Now, what we didn't talk about was how you, if there was one where it was possible, or at least it wasn't impossible, how you would actually do it. Now, Euler, he said that if all of the vertices, or all those nodes, had an even number of bridges, he said that it would be possible. But he never proved it. He just said that. But he was very famous, so everybody believed him anyway. Now it turns out that he was true. That somebody else proved that it was possible. Let me draw another one. And this will be a challenge problem for Kayla and also for Erin. Because they sent me some mail with a question about the problems. So I'm going to draw this one. this, yeah, is going to be, you can see, it's got a lot more bridges than the previous ones. But this is going to be a challenge problem for you, because if I look at each of these nodes, that the number is even on each one. 4, 4, 4, 4, 4, 4, 4, 2, and 2. None of them have an odd number at all. Now, Euler said that therefore it would be possible to make a complete circuit of this set of bridges if there was a town that had bridges like this. Now, this one is not as easy as the other example that Kayla did for us. And let me just give it a crack. I'll just try this. I'll do something like this. I'll go, let's see, I'll start here. I'll go boom, boom, boom. Let me go boom, 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 boom. Okay, well, I tried, but I didn't get it. And I can't even remember where I started because I didn't leave the space like I did on the other ones. But I don't think this one's going to be as easy, but I don't think it's going to be that hard if you stick with it. And if you try it and you think about how you could do it without getting stuck, maybe you can get it. And that's an example of one that you can do, but it's just a little bit harder. Okay? Good luck with it.